Hi, welcome back to the CE371 Soles lab videos. Today we'll be doing lab number 7, the direct shear test. And what this test will do is it'll help us build a failure envelope and determine the strength parameters for granule soles. Do note during this lab it's going to be pretty tedious, so ensure that you're following the directions in your lab manual as well as paying attention to the video, because one little mistake can mess up your results. Also, please pay attention to positive versus negative vertical strain. Let's get started. Let's dig in. So the first step of this lab is we're going to go ahead and pull a pin that's connecting the loading head to the testing apparatus. Don't worry, you don't have to sweep the clip. And we are going to remove the loading head right here. So what we'll do is just place the pin over the side. We're going to take the loading head, place it over here at our workstation. Note, we have 2 white nylon screws right here. We're going to go ahead and unscrew these guys.
Any day now, son.
But usually there's like...
So once we've gotten these guys, we're going to place them off to the side. Now what we're going to do is we're going to take the top portion of our loading head and we're going to ensure that these green screws are flush with the bottom portion of the base head right here. So if they're not flush, we're going to take our Allen wrench and we're going to use these to make sure that all 4 of them are flush. So you take your Allen wrench, turn it clockwise, will advance the screw. Once they're flush, we're good to go. So the second portion of this lab is we're going to remove the 2 silver portions of the loading base right here. We have this guy right here. Kind of looks like a weird looking volcano. So you're going to take him, place him off to the side. And then the next portion, we're going to take the silver base, place that off to the side as well. And then we're going to reassemble our loading head. When we're doing this, we're going to reinsert the nylon screws, but make sure you do this hand tight. Note, again, make sure it's just hand tight. So the third step in this lab is we're going to reassemble the loading head with the silver portions. So when we put the 2 silver portions back into the loading head, we want to ensure that the grooves right here are facing upwards and that they are perpendicular to the direction of travel. So in this instance, the loading head will be traveling this way along this axis. So we want to ensure that our grooves are going to be perpendicular to the direction of travel. So we'll put the base first. Then we're taking the top portion of the silver loading head, and again, we're going to make sure the grooves are facing, again, perpendicular to the direction of travel, but in this case, the grooves will be facing down. Once we've done this, we're going to go ahead and measure this on a large scale, the weight of the loading base, to make sure that we have the nylon screws in the weight, as well as the 2 silver portions of the loading head. And make sure we record this weight. So what we're going to do is we're going to now measure the inside diameter of the loading base head right here. So make sure you take it in 3 different spots. And then we'll take the average of those 3 diameters, and that'll be our diameter. So the next step is we're going to go ahead and reinsert the loading head back into the testing apparatus. Do note that when you're putting this in here, make sure again that it's, the nylon screws are finger tight, and that when you place it in here, that the grooves do not shift from perpendicular to the direction of travel. Also, when you reinsert this pin right here, make sure that you're doing so carefully, because if you do it too quickly, the pin tends to get caught and stuck. So. You need to do it slowly and then kind of turn it a little bit back and forth. It helps the pin reinsert into the system relatively easy. So the next step in this lab is we're going to measure the initial height.
All right.
So the next step in this lab is we're going to measure the initial height. And I recommend using so we have to have like a common base point right here. So I recommend taking your metal bar, placing it right here on the testing apparatus, and then using that as your benchmark to measure the initial height of the loading head right here. So do note, make sure when you're using the calipers to measure the distance down and the initial height, you're using the bottom of the calipers. If you're able to use the top right here, I'd be very impressed. But ensure that you're using the bottom portion here of the calipers, and then you are measuring from the top of the base right here, or the top of the metal bar, to the dimple in the top of the loading head. So once you measure that, that's going to be our initial height. So the next portion of this lab is we're going to prepare a sample. First, we're going to remove the top silver portion of the loading head, place off to the side. Then we're using an auto sand right here. And again, remember this this test is for granule soils. And we're going to apply our first lift. We're going to do 2 lifts of the soil. Each lift will be compacted a total of 25 times, roughly 3 inches, 3-inch drop using this this hammer right here. Be careful not to spill any sand, so be very careful when you're transferring over the sample using a teaspoon. And again, we're going to use our standardized hammer right here. We're going to drop it roughly 3 inches, 25 times. Scarcify the surface of the soil. It's good practice. It's not going to do too much with the auto sand, but scarcify the surface of the soil. And we're going to apply our second lift. And we want our second lift to be like roughly half an inch below the top portion of the loading base. So do note, make sure that you cannot see the interface line between the top and bottom portions of the loading head. If you can't see it, it means that your sample is not thick enough. So make sure that you're covering the interface line between the top and bottom portions of the loading head. So the next portion of this lab is we're going to put the top silver portion back into the loading head. Notice that we do want to make sure the grooves are going to be perpendicular to the direction of travel. Once again, direction of travel going this way, that means the grooves will be running this way, facing downward. So we're going to place that in there, and we're going to use our hammer to tap the top of it a couple times just to ensure that it's seated properly and that it's level. After we've done that, We're going to take our metal bar, place it right here on this portion here of the loading head. And we're going to measure the distance from the top of the bar to the dimple and the silver portion of the loading head right here. And this is going to be our new height. So we're going to make sure before we move on to subtract that new height that we had. So from that new height, we're going to subtract the original height, which will give us the height of the sample in the apparatus. So next up in this lab is we want to pivot this bar right here on top of the sample. And we want to tighten down these black knobs right here until they're in contact with this bar here. We want it to be roughly level. So when you're doing it, just ensure once you tighten it down, just take a look at it from the side. Ensure boom, roughly level or golden. Next part is we're going to tighten down this bar right here. And we want it to have a good, healthy contact with the top of the dimple right here. So again, we don't want to tighten it down too hard where it's bearing on top of the soil sample really hard, but we want to make sure that it's got a good contact to it. So once I feel like it's bearing down, I'm going to go ahead and stop, leave it right there, and I'll move on to our next step. The next part of this lab right here is we're going to remove the nylon screws. It'll be a little difficult to remove, but once you remove, just place them off here to the side. Next step is ensure that the nylon screws are removed. We want to make sure that those guys are completely removed, because if we don't, we're going to be testing the shear strength of the nylon rather than the shear strength of the soil. So now that we've removed the nylon screws, we're going to go ahead and take our Allen wrench right here, and we are going to do a 1/4 of a turn clockwise on each of these screws, these Allen screws right here. And what that's going to do is it's going to give us a little bit of separation between the top portion of the loading head and the rest of the loading base right there. So if we just do a 1/4 of a turn clockwise on these 4 Allen screws right here, that's essentially going to create some separation between the top portion and the lower portion of the loading head, allowing for there to be room to test the shear strength of the sole rather than like any friction that would be in between the top and lower portions of the loading head right here. And once we've done that, we're going to go ahead and put our 2 gauges in position to measure the horizontal and then the vertical displacement right here. So we want our first plunger right here for vertical displacement to rest perfectly on top of the loading pin right here. And we want to have sufficient room for upwards and downwards travel. So we're going to put that right there and make sure it has enough room. If we need to have a little bit more downwards travel, then we can just lower this down right here, gives us a little bit more room to work with. And then we're going to have our horizontal gauge, which will be right here, and already be touching on the apparatus right here. But I want to make sure these 2 are both set up. Once they've been set up, we're going to zero it. In order to zero this, it's not like we have to do in some funky calculator, funky like pressing the buttons or anything. We're literally just going to turn this gauge until we have our needle marker right here will be on 0. So again, we're just going to turn this guy until our needle right here will read 0. So now, once these both read 0 and they're placed right here and here on the apparatus, then we're zeroed out and ready to go ahead and get started. Now that we've tiered the gauges, we're going to go ahead and tear the machine. So what we're going to do is we're going to press this tear button and we're going to hold it down until it reads 0.0. Now note this will probably take a little bit of time, so just be patient with it. There we go. So we have 0.0 there. Now we've teared the machine. So before we get started on running this, we want to make sure that it is in forward. Most likely your machine will be in forward from where previous group had has back their sample back to the starting point. So we make sure it's in forward. And then before we run it, we want to make sure that we have somebody reading the vertical displacement, the horizontal displacement, and somebody also measuring the shear load. So again, we have 3 people that are going to be monitoring 2 gauges and then the load right here. So when we start, we're going to go ahead and start running the load, running the test. And as we're running this, we want to run it until there's 4 consecutive decreasing loads. Once there are 4 consecutive decreasing loads, then we know that the soil has failed in shear, and that we can go ahead and stop our test. And once we do that, let's say we just had those 4 consecutive decreasing loads, we're going to click stop. We're going to float into reverse, and we're going to run it until the horizontal displacement goes back to 0, where our starting point was. So after we back the sample back to the horizontal displacement equal to 0, we're going to go ahead and remove the vertical displacement right here. We're going to reinsert our nylon screws, and we are going to essentially pull the weight off of pull the loading pin and the weight off of the sample. And again, we want to make sure that these nylon screws are screwed in pretty tightly into the sample. We're going to completely remove the sample, weight on the large scale, take the volume and the weight of the sample to determine our moist unit weight. Once we've done that, you're going to go ahead and repeat the lab for a different soil to test the shear strength of that soil. And once you finish that test, go ahead and make sure your lab area is cleaned up. Check with your lab instructor before you leave, and have a good rest of the day.